procreating, and they just see their world just getting completely disrupted, right? For sure. Okay, so the non-human life forms for sure are a victim of injustice. But what about humans? Can you tell us a little bit about that?
Because industry pollutes and don't get sleep, people get disease like arsenic and
some sectors are responsible and some sectors are the sufferers.
Exactly. So not everybody is equally contributing to climate change. Do you agree that an industrialist that has a private jet has a, what about 20,000 square foot mansion with 8 SUVs, only vacations in New Zealand and Thailand and da is very different from the impact that you might be having right now? Do you agree? And imagine a farmer that's growing moong dal here. Yeah, Bijapur, which I believe is a place where a lot of moong dal is grown, I think. Right? Or sugar cane. Right? They would not be causing so much of an impact. So this is I think a nice image of what I think climate injustice is like. Do you see some injustice over here in this scene? What do you see actually? First of all, and let's see what do we see in this picture. This is a picture of the highway between Delhi and Gurgaon.
Lot of traffic.
Yeah. There's a traffic jam, right? Okay. But can you differentiate the kinds of vehicles here?
Private and public.
Public and private vehicles, right? Who are responsible mainly for the traffic jam here? Private vehicles. But who is also getting stuck? Public transport is getting stuck. So would you agree? So I would like to propose a definition of climate injustice. The most responsible suffer the least, and the least responsible suffer the most. And that is what is going on. Not just between India and other countries, within our country as well. The ones who suffer the consequences of climate change, of flooding, of extreme heat, of water shortages, are usually the most vulnerable people who barely consume anything. And the ones who cause it are the relatively well-to-do. So one way to know what your footprint is, basically look at your wealth. There is a direct correlation between extreme wealth and extreme impact on climate. They are married together. Very few people are able to increase their wealth and not hurt the earth more. They almost go hand in hand. So, would you then say that this is a picture of justice, right? This is what should happen. If you want to drive a private car, then you deserve a traffic jam. But you have a choice. You can take the bus. So this is what we're trying to get to. We're trying to get to a state where the ones who make better choices should suffer less consequences. So for example, you as architecture students or civil engineering students, you design a building with people that hurts the earth less, then you should actually have better conditions of living than the people who make these mindless mansions made of glass, literally creating a greenhouse in the tropics, which you should not. Right? Okay. So now we looked at climate and injustice. A big part of what we're going to do today is we're also going to unpack the idea of air conditioning, which I think we all are using right now. Right? But it's okay, that's the reality. We're trying to undo the reality. It's going to take some time. Can somebody here, can you read the words? I know it's a little hard. Sorry, I didn't know how. Thank you so much. You can read the word air conditioning, right? Can somebody here talk a little bit about how air conditioning is a source of injustice on this earth? Air conditioning is good, it gives you comfort, but it also causes injustice. How?
I would say
is cool. Right now, to cool our space, we are heating everybody's space. Literally, AC is what? What is an AC? It's actually just a heat pump. It's just taking the heat from here, using a lot of electricity to raise its temperature further, and then dumping it onto the earth. So to cool our small little homes, which our clients pay for, we are heating the home of all life. That's one source of injustice. You know what it's like to walk outside a wall of ACs, right? You might have gone to some shopping complexes where inside, when you're paying money, lots of comfort. The moment you're done being a consumer, you now suffer the heat that you were rejecting earlier. Okay, that's one. There's a couple of other very important aspects to air conditioning. The gas there is refrigerants that are released, absolutely. But in terms of injustice, we're talking about imbalance. That is also causing heating, by the way. It's a big part of it. We will look a little bit at the refrigerants of air conditioning as well. I think you have already perhaps studied this in your program, but we'll revisit some of these concepts. But there's another thing besides the gas. Sorry? Actually, ozone depletion is not the issue with air conditioning anymore. Earlier, the gases that were used were called CFCs, chlorofluorocarbons, but those have been banned for a long time. So that's not the problem. Global warming is the problem. Global heating, sorry, I should not use the word warming. Global heating is the problem. But there's another aspect of air conditioning.
Consuming energy.
Okay, so what does that cause? By the way, how much energy does an AC use compared to, say, a fan? Both are systems for cooling people. Yeah? Can somebody say, what is the energy consumption of a typical 1 ton AC? 1.5 ton AC. A typical split unit is about 1.5 ton. Compared to a ceiling fan.
Ceiling fan about 60 watts. This is 1000 watts. 1500 watts.
So, can you imagine that? Something that is 1200 versus 60. So, if we turn off one AC, how many fans can you run with the same energy? 20. Okay, so now imagine peak summer in Bijapur. All the AC owners at 2 o'clock after lunch, or maybe even before, turn on the ACs. And there's a whole part of society that doesn't have ACs, has only ceiling fans. And there's a power cut. Yeah? Who suffers the consequences the most?
One who doesn't have
The AC users suffer the most. Usually they also have diesel generators. The AC users also have backup power to continue consuming. And they don't even know that they caused a power cut. They of course feel, oh my god, power cut. Hello. Maybe it's because of your air conditioning. So isn't that a classic case of injustice? The fan user is sitting there using a 60-watt fan and their power goes off mainly because of this preponderance of air conditioning that we are now using. So air conditioning is a great subject to actually think about and undo, because it really signifies and symbolizes all the inequality that we are causing through our development. I'm sure we all agree that we want to develop, but equally. We want to make it an inclusive development, right? We don't want our development to be a source of violence, economic and ecological violence upon other people. That is not a fair, just society, and I'm sure we want to be a fair and just society. Okay, so now I'm going to show you another example of possible injustice to do with the world of architecture. You all have heard of green buildings. I'm sure you've even done courses on IGBC, LEED, GRIHA, etc., right? Yeah? So I have a question. If you spot the green buildings here, this is a very well-known LEED platinum rated building in Mumbai. And tell me who here is living in the green buildings? These buildings, right? But do you think they ever get green building certification? What do we call green buildings? When you think of green buildings, what do you think of?
Energy sufficient.
It consumes resources less in every aspect.
Right, exactly. Right? So now would you then question this whole idea that says that I don't care about the size of these buildings. I don't care about the fact that there are 3 people living in 3,000 square feet. But I will only look at the tiling, I will only look at the water flow fixtures, I will only look at the lighting, and I will give that person a green building rating. And this person is considered to be the problem. The poor are always a problem in the climate. In the water environment, all the dirt comes from the poor people. Right? All the gandi jagah is all the slums and all that. That's what we call the dirt is. But if you were to look at the climate impact, who are the dirty people here? The climate pollution is coming from here, by the way. They are not causing climate change. But when the flood comes, who is going to suffer? The one in the high rise or one in the low rise? Another, our conception of green buildings is also skewed. It favors again the view that first you can consume as much as you want, but just make it green consumption. Don't question the total amount of consumption, just make sure it's green consumption. Buy a massive SUV, but just make sure it's green SUV. It's a fuel efficient SUV. This is what's called greenwashing, really, basically. It allows the people who are the most culpable, most responsible to walk around with a sense of, I'm doing my bit. I buy organic strawberries from New Zealand. You know, I do organic but from New Zealand. You know, it's hypocrisy. Okay, so we're going to unpack this issue of buildings, carbon footprint, all of this through what I would like to suggest as a framework for understanding most subjects. I'm sure as students, very often you are just told, you have to study this because you have to study this, and we start doing. And as architects, as engineers, we like doing, we like using our hands. We consider ourselves very hands-on people, right? In fact, this whole training is going to be hands-on training, which means you're going to have to bring your calculators out, your pen and paper, and actually do hands-on stuff. But do you agree that if you just act with your hands without your heart and your head along with it, then you're just a mechanical robot? So we don't want to be mechanical robots, right? We want to know why are we doing this carbon footprinting of buildings, right? So I'm going to try and provoke you with some facts and figures that make the buildings issue an undeniable issue in terms of your actions as architecture students, as architecture professors. And then we will talk a little bit about what are some of the ethical aspects of buildings. We've already touched a little bit about this. What are some of the ethical considerations why it is high time we start acting? And then we will look at what can we do about it. And the rest of the training sessions, this one and the next one, are going to be about the doing. Yeah, but let's orient ourselves. Okay, how many of you, by the way, have friends, family members who deny that we are in a climate emergency? Who actually blatantly disagree with you, saying this has happened before. Ye to hua hai pehle. It's just a Kaliyug, it's a whatever. They explain it away. How many of you really have experiences and have difficulty convincing your social circle that this is real? Nobody. Nobody has faced any kind of denial, climate denial around you. Wow, I wish I was your. Okay, so, but you've experienced this in the past when people are wondering, is this all exaggerated? This is all a scam by the solar PV companies to get us to buy solar panels. Kuch power problem nahi hai. We will generate more and more coal, no problem. You've all experienced this, right? So you might find in the next few minutes some very compelling, hard-hitting, undeniable facts about the situation that we're in. And use this, all this material is for you, by the way. Use this to strengthen your arguments. Okay, so the first thing, by the way, we're going to look at the environment, economy, and the education system. We're also going to look at how the architecture education system is in need of reform. And then tomorrow, my ally, Savita Krishnamurthy, Narayan Murthy, sorry, I keep going as Krishnamurthy, Narayan Murthy, is going to talk a little bit more about educational policy, how it can be reimagined. And actually, Professor Tansali here, I'm going to talk a little bit about him later, but he was instrumental in changing the syllabus of the VTU to integrate all of these ideas into the syllabus. It's now there in your curriculum from here on. Okay. So, the first fact that there is an issue with buildings and climate change in India is this. That buildings already, this is by the way 2010 figures, they need to be updated, but a study has not been done yet. But buildings consume close to about 40% of all energy in India. Just buildings, not industry, but 40% of energy consumption happens through buildings that we construct. Can you imagine that? That's a lot. Which is why architecture, I'm sure you'll are sick and tired of everybody telling you all that climate change is a big responsibility of architects. You know, you all have to really rise to the challenge. One of the reasons is this, actually. And by the way, that is true even though India has built only 30% of the buildings that will stand in 2030. Imagine, we are only 3/7 of our way through to the building boom. We already are constructing so much. I mean, look at Bijapur, so much construction is going on, right? But still, this is the tip of the iceberg. A lot more construction is planned. So can you imagine how much energy buildings will use once we are through with the building boom? Where will the energy for other purposes come from? Where will the energy for farmers, for irrigation, for example, come from? Where will the energy for small scale or medium scale industry come from? A question to be asked. So, I would like us to focus a lot on the energy issue. Yes, we will also talk about building materials. That's also important. But energy use of buildings is going to be a big part of whether we make it as a civilization or not. If we do nothing, we are really headed for an absolute crash against the wall. Okay, so that's one thing. Now, can you imagine a country that is building so much? Almost all of it is from now on going to be air conditioned. We are not building too many naturally ventilated buildings anymore. Even residential buildings are getting centrally air conditioned. Yeah, I'm sure you can agree. Yeah, to a large extent. I'm not saying zero naturally ventilated buildings, but a lot. Now air conditioning is becoming almost a birthright. That from the moment I wake up, I get up in an air conditioned environment, I stand there, wait for my air conditioned Uber or air conditioned car, like I came in today, right now. Then I come into an air conditioned hall, then I'll go back and sit in an air conditioned mall, then I'll go to an air conditioned coffee shop, to an air conditioned restaurant, and go to sleep while watching TV in an air conditioned room. That's our lives are going to be in air conditioning. All the time. So then, what happens to a country that is going to build so much and most of it is going to be air conditioning? So we did a study a few years ago to look at how much air conditioning India has in the year, let's say 2023. Okay? Let's look at where we are. 2023. And let's look at where we're going to be in about 12 years from now. So in 2023, India has about 26 million tons of air conditioning, central air conditioning, and about 74 million room ACs. 74 million room ACs India has installed. Is that a big number or a small number according to you? For a country of the size of India, is that small or big? Small, right? We have a population of what? Right? 1.4 billion people. 1,400 million people. So if you were the head of Daikin or Panasonic, you would be like salivating. India is like the #1 unsaturated market for air conditioning. Which which is why Amitabh Bachchan, all our big stars are all on television telling us to buy air conditioning. Now we even putting Wi-Fi in the air conditioning or whatever. We don't get respect from our in-laws unless we have air conditioning. There are ads about this. There's ads that tell us office-like cooling at home. Blue Star. So we are going to be told that without air conditioning we are worthless. Like your life will be horrible without air conditioning. So what is going to happen to that? A very modest estimate is that by the year 2035 this will have almost tripled. Imagine in 12 years we are going to triple the amount of air conditioning. So air conditioning was sort of brought into the modern world after World War II, say around 1940. India started having its first ACs. So imagine 1940 to 2022, we got 74 million ACs in about 80 years. But in about 12 years, we're going to triple it. This is how fast it's moving, this issue. Yeah? Okay. Now, a lot of us, think that, oh, that's because of, this is primarily because of the population increasing. Yeah? Of course the population is increasing. No doubt about that. Yeah? But I would like to point out, very often this argument is made that the solution for climate change is reduced population. How many of you heard this? That population is the problem. And once the millions of people die off because of climate change, justice will be restored. And now all the green people will be living on the earth. In fact, the ones who will be living are the ones who were the most responsible. Who will again continue to destroy the earth, and within 30 years there will be another wave. And this is how we will keep cleansing all the poor people, all the ones who never caused it. And what will be remaining is a bunch of hyper-consuming megalomaniacs. So, how do we prove that it is not the population problem, it is the lifestyle, it is the consumerist lifestyle and the capitalist economy which only understands one thing: growth, 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 growth. 10%. Every year we want to do 10% GDP growth, right? That's what we keep hearing from our politicians. 8 to 9% growth every year. What does that mean actually? That means more energy consumption. Does anything in nature grow at 9 to 10%? Do forests grow at 9 to 10% a year? Do rivers grow at 9 to 10% a year? Is the atmosphere growing at 9 to 10% a year? No. But all these dustbins, these are all massive dustbins for us. Water is a big kachra ka dabba. Land is a big kachra ka dabba. Atmosphere is a big kachra ka dabba. The kachra ka dabba is not growing, but we want to put 9% more kachra in it every year. So, here is a statistic from the Ministry of Statistics and Program Implementation of India. This is not some environmentalist trying to demonize this situation. Here are energy consumption per capita. So you take India's total energy consumption, you divide it by the population, and you come up with the per capita energy consumption. Now, this is tracing it from the 1970s all the way to 2010, 2011. Okay? So in 2010, it was around, let's say, 1200 kilowatt hours per year per person. Yeah? That's the average in 1970. And what is it now? So let's imagine another bar here. It might have reached maybe 2023 over here. So let's say it's reached 6,000. From 1970 to 2022, which is about 50 years, our energy consumption per person has gone up 5 times. I'm sure our population has not gone up 5 times since then. So, sure, number of people on this earth are increasing, but each person is consuming. Imagine one of us is consuming as much as 1.5 family on an average basis of the 1970s. And one interesting feature here, I don't know if this is visible. Yeah, okay, this is maybe a better feature. So now imagine a country which has a lot of energy needs, but actually is an energy poor country. Do you all agree that India is an energy poor country? We are a net importer of energy. We all know this, right? This is not shocking news, I hope. Yeah? So what happens to a country that is energy poor but has a lot of energy needs? And I'm the energy minister of the country. What would I keep doing to keep this story going? I don't have the energy, but I need more energy. What do I do?
Import.
Produce, but more than that, import. Right? If I have an income of 10,000 rupees, but I want to spend 30,000, what do? I bring a credit card along. I live on credit, which would be fine. But if every country in the world wants to live on credit, it can't. There has to be somebody who has to lend. And what's happening is every country is becoming a net energy borrower almost. So this is the truth of our energy dependence. This again has come from the Ministry of Statistics of the Government of India. This is India's import history from 1970s to 2010. Okay? Can somebody see that there is something bizarre going on at this time? Something changed in the 1990s. So the more grey-haired people here might know the answer to that. You might have not seen this happen in your lifetime. What happened in the 1990s which can explain some of this? What was the historical phenomenon that happened in 1990 around? IT boom, yes, but that was part of another larger overarching phenomenon. Sorry? Industrial Revolution was much before that.
This one came open to the India is open to
India is open for business. India became neoliberalized. India became liberalized, a liberal economy. We became a global economy. Till then we were a relatively socialist closed economy. In 1991, under the Narasimha Rao government, India had to open up for business and bring in the multinational brands. That's when India became globalized. That's when we started having, I don't know if you remember this television ad called Onida, Neighbors, Envy, Owners, Pride. Imagine, we were now in the world of not being happy with what we have, now we have to cultivate envy. We have to consume so much that the person next to us is like, wow, how come they have a bigger television? That's what this leads to. That's it. You have 1 billion people envying each other. Greed is good. There was a term coined by Thatcher and Reagan. Greed is good. Through greed comes more accumulation of wealth. Through more accumulation of wealth comes more jobs. That's the logic, right? Through my great income, I will give back to society. But first I will plunder the hell out of it. First I will accumulate a lot, and then I will give a little bit of charity and become the hero. And that's what we legitimize. So, the story of climate change, the story of energy consumption has got to do with economic growth. Unless you get this, fixed in your head, you will be constantly mystified by why this is happening, and we will only be planting trees, which is all very good. But responding to these socio-economic phenomenon through planting of trees is not the answer. We need to look at root causes. This is reacting to the situation. Trees are a band-aid. But we are leaving the root causes unaddressed. And what we're going to be doing today, carbon footprinting is a way of addressing root causes. It helps you identify where my problems lie. Yeah? Thank you so much. Okay, I'll skip this. Another thing that you should just keep in mind, that residential energy consumption is going to increase 8 times in India. It's not a small amount of growth. In 18 years, imagine an 8-fold growth in energy consumption. And commercial energy consumption is going to grow about 5 times in these years. Yeah? So we're dealing with a inexorable rise. It's not like a linear sort of slow rise. It's something that is going up quite dramatically. A good picture to show that, by the way, this line over here is India's electricity consumption since 1970 to 2010. You can see that you multiply the 5 to 6-fold per capita energy consumption, and India's population has doubled between 1970 and 2022 approximately. So you multiply the two, you have about a 10-fold increase in energy consumption. So it's not mainly population, it's mainly per capita energy consumption growth that is fueling this. Okay. Now, a lot of us say that, okay, but India has to grow. We have not been the main causes of climate change in the past, that's true. Historically, we are relatively new to the gang of looters. We are now in a gang of looters for sure. India is number 3 in the world in terms of carbon emissions. First is US, second is China, third, more than all of Europe combined, is India. As a total, we have a lot to answer for. But we are new, I completely agree. So, a lot of you must have faced this dilemma that, okay, but we have to grow. Yeah? And a lot of our friends, family members also be saying that, listen, we cannot afford to do environmental friendly things. Our time, this is the time to grow. Then once we do all the growth, we will put in better technologies and all that, and then we'll become clean again. Okay, so say you go with that argument that we need to grow at 8% a year. Now this is again information from India's own planning commission. It shows that if India wanted to grow by 8 to 9% every year, this is how much energy it would need to keep generating. This is power generation capacity has to keep going up like this. Yeah, this red line for 8% growth. This curve is the actual energy generation curve. It is growing, but there is a constant delta. Constant delta. Which is why we still have power cuts. So even if you wanted 8% growth, you have to somehow make this much energy, which is what you have, work like this much energy. So you can at least say that we need to be more efficient in terms of our energy use, so that we can get the growth we want even with the same amount of energy. Yeah? Okay, so I've exposed you to a lot. I'll take a bit of a pause. Any questions that are bubbling up at this point? Anything that you would like to say in response? Exactly. How do we plug that gap? That's going to be a lot of what we will talk about today in terms of energy efficiency, in terms of sustainable cooling systems. There's a lot more. Yeah, I'm sure you'll have done some of this stuff. Anything you've done around energy efficiency, lighting energy efficiency, cooling energy efficiency, pumping energy efficiency, better materials which need less embodied energy, sun-baked bricks versus fired bricks, for example, autoclave aerated concrete blocks versus conventional concrete blocks, for example. All of this contributes. Yeah? So your work has already been helping this energy work like this energy. But I just wanted to frame it that this is what we should really be thinking about when we are doing our work. Okay, any questions up to now? Okay. So now we're going to deal finally with the subject of carbon dioxide. We've mentioned that all this is happening because of carbon dioxide. Yeah? Okay, how many of you truly understand what is causing this global heating? How is carbon dioxide responsible for global heating? Can somebody here very simply explain this phenomenon to us? Did you get it? Sorry?
It does not allow reflected sunlight to go back into space.
Right. Okay. Do we we have any other example in real life which is sort of like that? When do we have a situation in life where the sunlight is able to come in, but is not able to get out? Glass. So you park a car in the sun for half an hour, what happens when you go back in? You're bouncing around like a cat in a hot tin roof, right? Because it's so hot. That's what's happening to the earth. So CO2, carbon dioxide, is like a thin film of glass that we are developing, right? And the glass thickness is increasing over time. Thanks a lot. Is increasing over time. So, how many of you have heard that CO2 has been going up and down historically? In the ice ages also it was there. There was also global warming many eras before, during the Jurassic age and all that. All of you have heard that there is a cycle in terms of CO2? Okay, now this is a graph that shows carbon dioxide levels from the year 1000 onwards. There's also records before that, but it almost looks the same. And this is the current state of CO2 levels. Do you see that there is a bit of a cycle here? There's an up and down a little bit. You see this? You see this? A slight sinusoidal wave. That's what people refer to when they're saying cycle. Yes, it goes up and down. But do you call this a cycle now? This is what's going on now. It is no longer a cycle. It is now just a rocket launch. It's unstoppable. So, CO2 levels had never gone above 300 what's called parts per million. Do you remember in chemistry in school, you would have a number that says air is composed of 70.9% nitrogen, 20 point something oxygen, and CO2 was how much? 0.03%. That comes from here. 300 ppm means 0.03%. Now, what do you think the CO2 level is in the atmosphere now? A number that has never gone beyond 300. What is the CO2 level today morning? Does anybody know? Where are we? This was 375 was some time ago. What is it now? Yeah. This was almost 1 year ago. 419 parts per million. The safe level is considered to be 350 ppm. If we want to remain within 1.5 degrees of global heating, the almost universally accepted value of CO2 in the air is 350 ppm. We are at 419 today. Yeah, we've gone faster. And you see the cycling, it's there. This is a record that goes to negative 800,000 years. Yes, there is a cycle. But it has never gone up above 300. Now, this is what it's doing. I know this is tough to see and feel that we have a shot. How do we do this? How do we bring this back down? It's going up so fast. How are we going to bring this down? I mean, there are no simple answers. How can something like this be simple? So I'd suggest be skeptical of anybody recommending one big silver bullet solution. This requires all of us, to be figuring out what my role is going to be in this. I'm an architect, what can I do? I'm a textile maker, what can I do? I'm a dentist, what can I do? I'm a gardener, what can I do? So this is not just for one messiah, Elon Musk or whatever, to come and give us electric cars and some nice white boxes that generate energy forever, and we will be saved. Because the root cause would not have been addressed. So, the challenge is very stiff, and allow yourself to feel how difficult it is. It is really difficult. this is, sorry, this subject makes me very emotional because we really are in a dire space. We are about 8 years away from a lot of tipping points being reached. 8 years away. 2030 is a big time, big date for the future of civilization. If we don't really get our stuff together by then, there's almost no chance of us making it. Okay, now one of the teachers here mentioned that it is not just CO2, it's also Professor Akila. You mentioned refrigerants, right? So now a lot of architects often know about air conditioning causing a lot of energy consumption issues, but there is one other aspect which we often leave out, which is what's called the refrigerant leakage. Okay. How do we prove that refrigerants leak from ACs? Does anybody have proof that refrigerant leaks from ACs? Have you ever seen it leak? Nobody has ever seen it leak. So then why do you just believe me when I say that refrigerants leak from ACs? What proof do you have that refrigerants leak from ACs? Great. So then what do you do, Professor?
I put gas again.
You call somebody to put a gas. The fact that you're calling somebody to refill means what? It has leaked. Yeah? These systems are actually very, in the end, very simple mechanical and plumbing systems. They all have joints, they all have bearings, they all have screw threads, they all have nuts and bolts and everything. It's just a mechanical system with a refrigerant going in. There are many sources of its leakage. But you must be wondering, this leak, how much gas is there in an AC, by the way? In a typical 1-ton AC, how much gas is there in it?
400
Grams? Okay. That's in the more modern ACs, but a typical number, a good number to use, per 1 ton, there is about 1 kg of gas in it. 1 kg of gas. So you must be wondering, why is this 1 kg of gas so important? Right? It's such a small amount. और इसका leakage भी होगा तो कितना होगा? 10-15% a year, maybe? Right? So every year it leaks about 150 grams. Why are we wasting even a slide on this subject? Millions of ACs, but per AC is very less, right? Okay, so today we will learn about a concept of what's called global warming potential. This is part of knowing carbon footprint. Okay, how many of you can name a few greenhouse gases beyond carbon dioxide? Actually, carbon monoxide is not a greenhouse gas. It's a pollutant, for sure, but it's not a greenhouse gas. It does not trap solar heat. Methane, somebody said? Methane, right? Chlorofluorocarbons are not greenhouse gases. They are ozone-depleting substances.
Chlorine.
Sorry?
Chlorine.
Chlorine is not a greenhouse gas. Good try. How many other chemicals do we know? Let's try all of them. Sulfur dioxide, nitrogen dioxide, potassium dichromate, sodium chloride. Sodium chloride, nobody thinks. Thank God, salt is not a greenhouse gas. Salt is not even a gas. Okay. Have you heard of laughing gas? How many of you heard of nitrogen dioxide? N2O. It's a very well-known greenhouse gas. Now, all these refrigerants that we now have in our ACs, they are not CFCs, they are HCFCs. So this is how chemical engineers, and I can make fun of this because I have been trained as a chemical engineer, we often create a new problem and try to solve it. So CFCs were a problem. Guess what the answer was? They said, hey, let's put an H before the CFCs. We'll solve ozone problem. Absolutely, we solved it. Guess what we created? Global warming problem. Yes? Now they're saying, hey, you know what? No, HCFCs are not the answer. HFCs, we removed the wrong thing. We should have removed the C in between. So now we have what are called HFCs. They're even worse for global warming. So we are in the business of creating markets for ourselves, frankly. Engineers, chemical engineers always leave one problem in there. Say a computer person leaving one bug in there that they're then called to remove the bug. So we have a lot of these chemicals and they are called super greenhouse gases. So the reason why this is important is because of this. So this is a very important chart for us today. Okay, so on the left here are some well-known refrigerants that are used in India, and on the right is what's called a global warming potential. Okay, so now this term sounds very, very complex, global warming potential. So forget this, right? I'm going to ask us a question. Imagine we are an assembly at United Nations, and all of you are finance ministers of one country. Yeah? All of you are finance ministers of one country. So say you are all from Japan. You're in that corner. This corner, this central area is Europe, and that's US, and say this is India. Yeah? And all of you are trying to compare the size of your GDPs. Yeah? So that group, what will you report your GDP in? Which currency? I gave you a tough currency. Yen. Japanese yen. Okay? Okay. How will you all report your GDP? Euros. Euros. How will dollars? Everybody knows that. And what will you report it in? Rupees. Okay. So you say 1 billion yen is your GDP, you say 1 billion euros, you say $1 billion, and you say 1 billion rupees. Who has the bigger economy? How do you know that? How do you know that? Okay, fine, you said that. How do you know that? Everybody is 1, 1, 1, 1, 1. 1 billion yen, 1 billion euros, $1 billion, 1 billion rupees. What did you use? Conversion, an exchange rate to determine. So usually dollar is considered the official exchange sort of benchmark, right? So all of you will convert your GDP into dollars and report it, and then you will compare, correct? So usually in situations where you have multiple things to compare, you have to come up with some sort of benchmark. In the world of global warming, global heating, CO2 is the dollar. So what scientists have done is they have measured the relative heat trapping capability of lots of gases compared to CO2. So they imagine taking one jar of CO2 and keeping it in the sunlight, seeing how much heat it traps. Then you have one jar of methane, one jar of N2O. Then they did a jar of, okay, so these are all ammonia and carbon dioxide, propylene, propane, methyl fluoride, which is R32. All of you have heard of R32? Daikin is this AC that has mainly R32. It's called the new low global warming potential. It's a new green refrigerant. It's R32. Okay, we look at this global warming potential. Then R134 is. R22 is the most common refrigerant that is used. I'm sure this AC uses R22. And they measured the global warming potentials of all of those gases. And look at it. CO2 is considered 1, right? That's the basis, the benchmark. Look at one molecule of R22. One molecule of R22 is 1,810 times more capable of trapping heat than one molecule of CO2. Which means, if you have 1 kg of that gas leak out, how many kgs of CO2 have leaked out? Equivalent. If 1 kg of R22 leaks from your AC, how many equivalent kgs of CO2 have leaked out? 1,810, right? Now you must be understanding, oh wow, can you imagine 1,810 kgs of CO2 leaking out from one AC? That's a lot. So the reason why we are even talking about this subject is because these gases have very high global warming potential. One small little drop, it's like cyanide, right? when you talk about cyanide, you don't talk about how many kgs, right? One drop is enough. Arsenic, how much is it? Not so much in the water, right? But they are very potent. So refrigerants are like these super toxic chemicals in terms of climate change. So the quantity is not so important. It's the fact that they have a high global warming potential. Yeah? Okay. Now, you will often hear in the next few years, R32 is this new low global warming potential gas. What is the low? 675. Carbon dioxide is 1. And there is an AC, which is called a propane AC, by the way. R290. These ACs also exist. Yeah? Their global warming potential is 3.3. Imagine, even though this exists, this is called low global warming potential, 675. So be aware that there's a lot of industry interference. The way this happened, by the way, is there was a committee, an ISO committee, that decided that 700 global warming potential is, anything below that is low. Sounds a little convenient, right? That was because Daikin was a big part of that ISO standard setting committee, and they had a product that was at 675 already. So they said, let's make 700 the benchmark. So it's called green, this AC, but it is greenwashing. Okay, now the reason why you ever hear ammonia, yes, ammonia is used, by the way, but it has certain limitations in terms of its toxicity. So it's not a very high global warming gas, but you know the Bhopal gas tragedy with ammonia. I'm not saying that it's not used, but it has certain challenges when it's used in human occupied spaces. So for industrial use, it's often used. A lot of ice making plants are ammonia. Yeah? Okay, now how many of you have ever come across a story in your newspapers about these refrigerants being a big part of climate change? Almost never, right? You've never heard of this story in media. You hear about energy shortage, air conditioning, sometimes you might hear things about that. But the reason why we are not still now hearing about it is because currently the world is using relatively low amounts of refrigerant. This is a chart that shows how much refrigerant growth there is expected to be in the coming decades as the earth gets hotter and hotter. Imagine this, the ultimate negative feedback loop. As the earth gets hotter, we will now be installing more ACs, which will make it hotter. It's like a snake eating its tail when it's hungry. Hey, I'm hungry, I'm going to eat my tail a little bit more. It's kind of like that. It would be like a diabetes addict eating more sugar to get rid of diabetes. It would be that's bizarre. But this is what's going to happen. So you're going to start seeing that the world of cooling is going to beat the world of heating. Currently, the world is very heating dominated because most of the developed countries are in the global north where heating causes a lot of the carbon emissions. But as the global south and the tropics become hotter and hotter and become richer and richer, we are going to be buying many more ACs. Can you imagine if all of Africa starts using ACs the way we are starting to use now? Africa is not even talked about right now. But we all are trying to grow Africa the same way we are trying to grow, which is industrially through a lot of consumption. Yeah? And that is going to cause the situation. Okay, I'm not going to get into this. Okay, finally, I want to share with you two very compelling images before we go further. Now, I know a lot of architects are very visual people, right? Numbers and all you have some capacity for, unless you are unusually interested in numbers. Usually pictures are very compelling. Now, anybody who you know who denies that climate change is happening and how severe it is, I would suggest you show them this picture. Now, this is a picture of the polar ice caps, North Pole, in 1980 and 2012. I don't know if you can see this, but there's a faint line there. This is the outline of this. Approximately half is already missing. And do you know that by the year 2040, in the summers, the entire polar ice caps will melt. There will be no polar ice caps in the summer. In the winter, some of it will grow back. How many of you have seen the film Titanic? All of you have seen it? Okay, sad. But the only good thing about this story would be that if Titanic would have happened now, Leonardo DiCaprio and Kate Winslet would still be alive. They'd be a happily married couple because there would be no iceberg to hit. The only good part of the story is Jack and Rose would still be together. So that's really the only good thing. Can you imagine a world where you go through the North Pole and there's no ice? This is going to happen in 2040. If we do nothing. Another picture that is very compelling, very, very compelling. Now, because of the lighting, I can't show you this, but let me try. Okay, so this is the map of global temperatures since 1850 onwards. Sorry. And this is the 2010s. Even with this, do you see something that's going on? Do you see a change in temperature? Okay, when do you think this happens? Tell me, which row do you think the situation, like if this was your child or your sibling and this was their body temperature graph, when do you think the fever started? Which line? Yeah, around this? Lower? Much before? Okay. But I'm saying, at what point does it become almost irreversible? Like it doesn't cool back ever. Last 3, 4, right? 3 or 4, right? What do you think happened? So this is 1980, by the way. This is the 70s, 80s, 90s, 2000s, 2010s. In 1980, the decade of 1980 is historically very important. You have heard of Reagan, Ronald Reagan and Margaret Thatcher? Okay, these are two world leaders in the 1980s who decided that global growth or capitalism growth is the only way forward. There is no option. It's not negotiable. We have to grow as a capitalist economy where consumption becomes the bedrock of everything. And you can see that that means a lot of globalization, a lot of transport across the world using oil tankers, a lot of use of oil. This is when the oil use in the world increased dramatically. Again, proving that this story is not a story of just cutting off trees. This is a story of the growth of our economies at a level which cannot be sustained anymore, and all of that being energy-intensive, oil-based, fossil fuel-based growth. That's what we really need to press the brake on, is on use of fossil fuels and energy. Big time. Okay. A lot of us say that, hey, you know what, India is not the most affected of all countries. Why do we bother so much about climate change? It should be the West that should bother about it. The reason for this is a list of top 10 countries, or top 10 cities in the world that are vulnerable to the effects of climate change. 4 of them are from India: Mumbai, Chennai, Kolkata, and I forget which one. Sorry, 3 of them. Yes. 3 of the top 10 cities in terms of vulnerability to climate change in the world are Indian cities. So we really have to do something about this. It's going to affect us much more than other places. So the culmination of this part is that if we do nothing but more of the same, the amount of air conditioning related greenhouse gas emissions, and this is just air conditioning, there's much more than air conditioning, but just this will lead to so much carbon dioxide in the air that you would need to plant 1.35 billion trees a year to undo that damage through tree planting. How many of you really believe that tree planting is the answer to the climate crisis? It is one of the answers, partly, right? But I'm sure this makes it very clear. This means what? That means 1 tree per year per person. We all have a plant. And this is just for air conditioning related greenhouse gas emissions, which is maybe 1/5 or 1/8 of India's total emissions. So every year, each one of us has to plant 8 trees. And that is at current levels of growth. It is obviously not going to happen through just planting of trees. There's no space. Exactly. How much space does 1.35 billion trees require? Maybe we have to take over the entire state of Orissa and just use it for planting trees. I'm sure they'll be like, hey, listen, this is our home. So, planting trees is very important. But it was never designed, trees were never designed to address climate change. Imagine this, trees are just doing their own thing, and now suddenly it's like, hey, listen, you have another job, you have to solve the climate crisis for us. Like, what? I never signed up for this. I'll give you shade, I'll hold the water, I'll give you oxygen, I'll also absorb CO2, but I am not going to be solving your climate crisis problem. You have to solve the root cause of it. Okay, so the situation is this. Our wind space in India is increasing a lot. Our air conditioning component of this build space is increasing a lot. And we are running those ACs for longer time. Do you agree that earlier, I remember this even as a child growing up, we would turn on the AC for 1 or 2 hours in the night, very frugally. Everybody huddled around the AC, like 6 people would sleep in the same room because we had one AC in the house. And then you would turn it off after 2 hours, right? We use air conditioning like that. Do you know anybody who just uses ACs for 1 or 2 hours now in a day? And then turns it off so mindfully, it's rare. So, not only are we increasing the air conditioning space, we are using it for more and more hours. So imagine the multiplier, more wind space, more air conditioning, more hours. It multiplies with each other, and that's why we have such a growing amount of greenhouse gas emissions. Yeah? Okay. So I'll take a bit of a pause. Can I do a quick time check right now? It's 11. We've been going on for about an hour maybe, right? Does anybody want to take a loo break, like for a couple of minutes? Yeah, sure. 5 more minutes, got it. Okay, so we will maybe cover this by then. Okay, so here are all the intellectual arguments, right, that you can make. Now let's look at why this is an important issue in terms of justice. If you think of yourself as an ethical human being or an ethical society, why should we talk about it? Okay, so all of you architects here, you've done design projects, you are doing design projects, right now. One of you is designing a thing in Indore, right? One of you is designing a thing in which is the city, that bus terminal? Hubli, right? Okay. Are you compromising? Are you providing 2 designs in terms of fire safety? You provide option A, which is super fire safe, and another one that is a little bit fire safe. No, right? You don't provide any options. Fire safety is one thing. Structural safety, do you provide 2 options, low cost option with moderate safety, high cost option with full safety? You don't provide it. How many of you are likely to be in a situation where you have to provide 2 or 3 options in terms of green? Gold green certification, silver green certification, platinum certification. Fate of the planet? Okay, you choose. How is it even an option? How can we say that fire safety wise we never compromise? Structural safety wise never compromise. In terms of your plundering of the resources of the earth, okay, here's an option ऑप्शन मेन्यू कार्ड आपके लिए क्या, आपको क्या चाहिए इसमें से? We have to reach a world where it's not negotiable. I'm sure the future of humanity is not negotiable. We want full safety. We don't want like some chance at safety. The future generations will never forgive us. We chose silver because silver safety was more affordable. Okay, so this is an ethical situation. I have two questions here. Yeah. So there are two buildings here. Can you tell me which one of them is likely to have the higher cooling load in terms of air conditioning? Building A or building B? B, right? Okay, now.
Depends on the direction.
I know. But just looking at it on the surface, which is going to have more air conditioning heat? Very instinctively, you saw the amount of glass, you saw the amount of opening. This is India. You shouldn't be making greenhouses in tropics. Which is also likely to be the building that will apply for green rating. B. Right? This building, modest little housing society building, side house apartments, will never apply for green rating. This building, probably some IT office, yes, we will get green rating. But it has a higher cooling load. So, I don't know how many of you believe in the green building solving the world's problems. It's a part of the solution. But at some point, it was a real exercise. I'm sure all of you have heard that now almost any building can be passed on as a green building. You just have to hire a green building consultant. They will do some cosmetic changes, and you will get your points. Right? I don't want to make you cynical, but it's true that this great idea has unfortunately been reduced to paperwork. And it's all after the thought. It's after the fact. It's like a checkbox exercise. Now, if we do more of the same, then we are going to lead to a situation where 41 million AC users in India are going to cause power cuts for 1 billion people. So this is an ethical situation. If we continue to make buildings with higher cooling loads, we are going to be personally responsible for power cuts for a lot of people. Okay. Now, often these kinds of lectures are done by people who are engineers like me. We do not talk about the social implications often. And architecture is a deeply socialized field. It's a social field, right? It's about people. It's about where they live. It's about place making. So I'm going to share with you a few questions actually about why we must assert that this is not an environmental issue only. It's a humanitarian issue. What is at stake is human and non-human lives. One of the facts is, and this has already begun by the way, there is going to be a term that we're going to be using in a few years called climate refugees. By the year 2100, this is a report by IIT Madras, by the year 2100, India is going to have 100 million climate refugees. So we have all these smart city plans. Imagine these smart cities now. How hospitable do you think they'll be to climate refugees? So you make all these nice plazas and all this, sophisticated kind of world that we are creating, and now you have 100 million people who don't have a home because of climate change. We need to recognize that this is the consequences of our inaction. It is human displacement of a scale we have not seen before. 100 million people is like 5 Mumbais, 6 Mumbais that are homeless. Here are some statistics that show that the number of people dying because of climate change every year, by the way, are 315 million people across the world die because of some aspect of climate change. The number of people that died in the tsunami, a once in a generation disaster, was 225. So every year, we are losing much more people to climate change. The number of people affected by climate change compared to car accidents. If you open a newspaper, how many times do you see climate change is a big part of our problem. And how many times do you see two cars collided on the highway as the story? Not saying that that's not important, but our fixation with every other problem except for the climate crisis is astonishing. Our ability to look away, we have made it an art. Our ability to not look at the climate problem is an art that we are daily practicing and perfecting. Okay. So finally, and after this we will take a break. Maybe it's a good one. Can you tell me this air conditioning that's going on? What is powering this air conditioner? How does it run? That's simple, right? What? Electricity. Okay, but how does electricity come? How is it generated? In a thermal power plant, right? Mainly burning coal. In India, about 70% of our energy comes from burning coal. Please don't think it comes from rivers and hydropower and solar. That is 5 to 10%. The remaining is nuclear. 70% of India's, so this is coming from coal, do you agree? But I would challenge this, how does coal come? Coal is not just lying around.
Mining.
Mining. But how does mining happen? What is needed for mining to happen? Any of you want to be a miner here? I'll pay you a lot. You want to be a miner? Mining happens because of what?
Extraction of
No, but who makes mining happen? Miners. Human beings have to go into a hole in the earth for this AC to come. And this never hit me really, but this AC is running because today lakhs and lakhs of young children have decided to go to a coal mine and might not come out. This is what is causing this AC to run. This person, if this person refuses to go to the ground, we don't have an AC. And this sounds academic, but I had the great fortune of actually footprinting some of India's largest coal mines a few years ago in the Jharia coal fields near Ranchi. We were there for about 3 weeks. We never saw a person above the age of 40, I think. What does that mean, do you think? People don't live?
They don't make it fast.
They do it for the livelihood, but they don't live beyond
40.
the age of 40. The amount of dust they're inhaling, the cancers, the explosions, the disasters. For 3 weeks, we never saw a single leaf of a tree that was green in color. Everything was coated with a black/grey dust. Imagine seeing entire regions, actually forested regions, earlier, covered with a black and grey dust. We never saw a person without this. Everybody had like a kajal kind of eyeline. Everybody, except for the officers sitting in the air-conditioned offices. But everybody in the city had black dust all over themselves. So we as architects like to think of ourselves as artists. We draw lines on paper and renditions. Each of those has a consequence for this person and this person and this person. This person is actually a victim of what's called subsidence. You all have heard of Joshimath now?
Yes.
Subsidence has been going on in these villages for decades. Once you hollow the earth out, there are many practices that have to be put in place to ensure that the ground remains stable. You can imagine in a place which is quite used to cutting corners, cutting costs, that work doesn't always happen. Entire villages start sinking. So, I would like to just stop here that without these people risking their lives, all your architect's dreams are nightmares. the consequences of inaction in terms of energy use are deeply problematic. And frankly, these people, like I asked you, will any of you go to a coal mine? None of us will go to a coal mine. None of us wishes this for our enemies even. But yet, without them, nothing here is possible. This room will be uninhabitable if some people do not agree to be exploited.
The only source of energy in India.
So we have to really reduce its use. We have to increase renewables, but we have to reduce the use of energy in our buildings as much as possible. We have to come up with such beautiful, revivals of methods of architecture, ventilation, insulation, shading, thermal mass. We need to recover that intelligence. Gold Gumbas. All of you visited that. I was there yesterday. It's like a pilgrimage for me. How much energy consumption does a gold gumbas have? What's its rating? Platinum rating. It's like through the charts. It's zero energy use. So the answer is literally staring us in the face. Now we need to be smart enough to bring those kinds of techniques into our technology, into our context. That's the challenge. Can we bring gold gumbas type of cooling principles into a conventional building like this? Yeah? Okay, so we'll pause now. But before we go, any feelings that are coming up? I know this can be a little disturbing. How are we feeling right now about all this compared to how we were feeling before? It'd be nice to hear from some of the people who are feeling a little, maybe have been a little shy in the past to speak, but it would be nice to know how you're feeling. Yeah?
Switch off the lights and fans, even we are not doing it.
Sorry?
Can switch off the lights, fans.
Right.
In very college, school, course,
Yes.
when
When
you are not using
you're not using it, absolutely.
50% or 50% daily.
Absolutely. Maybe we need to practice a ritual of Earth Day every day. Choose 1 hour when we voluntarily say, this hour I will spend outdoors, I will not be indoors. But some of the students, please, how are you feeling about this? This is all making sense. Is this what you feel is useful? Because I know this is not footprinting yet. It's going to get there. Sorry? Great. Yeah. Great. A car-free day. Excellent. Excellent.
We are killing somebody at the age of 40 because of our electricity.
Still lesser. The average age is even lesser. Yeah. But who's going to compromise? But more than absolutely, completely agree. But even after that, we still have to find somebody to go into a coal mine first. So we have to recognize that the compromise is a human compromise. It's not just a cost compromise. And somehow we need to make this moral argument to our clients. There's a lot of ingenuity needed to make this. I would suggest really to carry pictures of all of this when you go to client meetings. My own sister is an architect, by the way. I feel we should show them images of quarrying, like all the marble and the granite they want. Where does it come from? Show them pictures. Show them pictures of coal mines. This is what's possible. If you use a high energy consuming AC and a system, this is what you're doing. And yes, you might lose a project or two. But don't we deserve to do something about them? Isn't the price of losing a couple of projects, but maybe becoming even known that, okay, this architect is an ethical architect. He's telling me what I need to hear. And hence I will give them the project. Maybe that's also possible. But something has to shift. Okay, so we'll take a bit of a break and then we'll continue with getting into solutions now. Right? We've done the head and the heart, now we get into the hands. And hopefully that will give us a sense of feeling empowered. And yeah. Thank you so much. Thank you. Yeah, please just take about 10 minutes.